guys, welcome to Distance Learning with Lee, where I make learning mathematics super easy. All right, today we'll be looking at a quadratic sequence, right? And we will be determining the general term for the quadratic pattern. We'll be determining the seventh term for the quadratic pattern, and we will also be determining which term, all right, on this quadratic pattern will be equal to 241. All right, what we already know with a quadratic sequence or a quadratic pattern is that there is a second common difference. Okay, so now with this sequence, we need to basically check that we do in fact have a second common difference, because if we do have a second common difference, we can confirm that it is in fact a quadratic sequence, and then we can start answering the questions. Okay guys, so let's get started. Right, so if you're given a sequence like this where you have 3, 13, 31, 57 and 91, right, your 3 is your first term, your 13 is your second term, your 31 is your third term, your 57 is your fourth term, and your 91 is your fifth term. Right, so what we need to do, we need to take, right, your term 2 and minus it term 1 and see what value we get. Term 3, minus it with our term 2 and see what value you get. Your term 4, minus it with our term 3 and see what value we get. And term 5, minus it with our term 4 and see what value we get. Okay guys, so what's 13 minus 3? Okay, 13 minus 3 is equal to 10. What is 31 minus 13? 31 minus 13 is equal to 18. What is 57 minus 31? 57 minus 31 is equal to 26. And what is 91 minus 57? 91 minus 57 is equal to 34. All right, so we already know, we are anticipating this, we know this, that with the quadratic sequence, right, with our first difference, right, we won't have a constant value, as we can see. All right, so we're going to continue. Okay, we are going to continue. Okay, and check if there is a second common difference. So 18 minus 10, what's 18 minus 10? 18 minus 10 is equal to 8, right? What is 26 minus 18? 26 minus 18 is equal to 8. And what is 34 minus 26? 34 minus 26 is also equal to 8. So here, right, we can see that we have a second common difference, which is what we want, right, for a quadratic sequence. And therefore, we can confirm that we are in fact working with a quadratic sequence. Okay, so we can start answering our questions. Okay guys, so these are the questions that we're going to be answering. Okay, the first one is we need to determine, the first one is we need to determine the general term for this pattern. What are they actually asking us? I mean, because I know that someone would have crammed that for this question, it's going to say determine the nth term. And if it says general, then already, you know, someone out there is going to be confused. Okay, guys. So if they're saying the general term for this sequence, it's the same as them saying you need to determine the nth term of the sequence, right? So you need to determine the formula that you are supposed to use for this sequence to get any term on the sequence. Okay, so let's not be deterred by the use of the word general term instead of the word nth term. Okay, guys. All right, let's not be confused by that. So we're going to get started, right? So to determine the general term for this pattern, there's certain things that we need to know, right? Okay, here you need to study, you need to know this, okay? Because we already know that when you're working with a quadratic sequence, so guys, I'm just going to move this out of the way just for like 2 seconds. When you're working with a quadratic sequence, you already know that you are working with a formula like, okay, I'm just going to move this to the side, and I'm also going to move that all the way to that side, okay? Okay, so when you're working with a quadratic sequence, we already know that Tn is equal to an squared plus bn plus c. Okay, that's the first thing you need to already write down when you're doing your working out, okay? And then to be able to determine the general term for this pattern, the first thing you should, this is the first step you need to do, right? We know that 2a, right, is equal to the second difference. Okay, this is the first thing you need to do. The second one is, after you've got your a, you need to use the formula 3a plus b is equal to the second term minus the first term, right? And once you've determined your b from using this equation, you need to use the equation a plus b plus c, which is equal to the first term. T1 is equal to the first term. Okay, so guys, this is very, very important. You need to remember this, okay? To determine the general term for this pattern, these are the steps you need to take. You need to remember that 2a is equal to the second difference. You need to remember that once you've got your a, then you can use the equation 3a plus b, which is equal to t2 minus t1, right, to determine your b. And once you've determined your b, you need to use the equation a plus b plus c, which is equal to t1. Okay, so this is something you really need to memorize and remember for when you are given a quadratic sequence in your mathematics paper 1 exam. All right, so we're going to get started, guys, with the questions and see how far we get with that. Okay, all right, so 2a is equal to the second difference. Okay, 2a is equal to the second difference. So if I go to my pattern, what was my second difference? Okay, on the on my pattern, on my quadratic sequence, the second difference, I'm going to be using a different color. The second difference is this constant, the second common difference. So 2a is equal to the second common difference, or the second difference, all right? Okay, and that is the value 8. Okay, so the second difference is equal to 8. All right, guys, so that's what we're going to do. We are going to be substituting that value into our equation and determining the value of a. So we said 2a is equal to the second difference, right? So this is our working out. Okay, so 2a is equal to 8, and then you simply just solve for a, guys, and a is equal to 8 over 2, right? And a is equal to 4. That's the first thing we need to do. The second thing I said that you need to do is we need to use the 3a plus b, and we said that the 3a plus b, right, is equal to your second term minus the first term, right? Second term minus the first term in our quadratic sequence. What was our first term in our quadratic sequence? What is our first term in our quadratic sequence? Our first term was equal to 3, right? And what was our second term in our quadratic sequence? Our second term was equal to 13, right? So 3a plus b is equal to 13 minus 3, which is equal to 10, okay? So this is our 3a minus b. Okay, T2 minus T1, which is equal to 10. All right, so we're going to substitute that 10 into our equation, right? We said 3a plus b is equal to T2 minus T1. Now T2 we said is equal to 13, right? And then our T1 is equal to 3. Sorry, guys. Okay, right. It's equal to 13 minus 3. And then we already know that our a is equal to 4. So you can just substitute that into this equation. 4 plus b, which is equal to 13 minus 3, guys, is equal to 10. You're going to make your b the subject of the formula. And you're going to be left with 10, right? Minus, okay, what's 3 times 4? 3 times 4 is equal to 12, right? Therefore, your b is equal to 10 minus 12, which is equal to minus 2. Okay. And then, guys, the next thing we need to do, we need to say a plus b plus c is equal to T1. So a plus b plus c is equal to the first term that we have in our quadratic sequence. Going back to our quadratic sequence, what's the first term that we had? Our first term is equal to 3, right? So we simply just substitute that. Okay. We simply just substitute that into our equation, which is a plus b plus c is equal to T1. Our first term is equal to 3, right? Okay, let me just do this, guys. Okay, it's equal to T1. We're writing it again. And then we're going to substitute. We said a is equal to 4, right? We said b is equal to minus 2. And now we are trying to get our c. Our T1 is equal to 3, right? And then we simply just make c the subject of the formula, right? And then you solve. So it's going to be 3. You move the other values to the other side. We'll be left with a minus 4 because the 4 moves to the right hand side, and the minus 2 is going to move to the right hand side. It becomes a positive 2, and you are left with a c that is equal to 1. 3 positive 3 minus 4 plus 2 is equal to what, guys? It's equal to 1. Okay, and then we are done. We already know now that our a is equal to 4, right? We already know that our b is equal to minus 2, and we already know that our c is equal to 1. So what's left for us to do is that we need to now substitute those values, right? We need to substitute those values into the equation of Tn. Okay. We need to substitute these values into the equation of, right? We need to substitute the values of a, b, and c into this equation, right? And we will have the general term for the sequence, right? So therefore, your Tn is equal to, what was the value for n? For a, it's 4n squared, and then plus b, right? So what was the value for b? It's equal to minus 2. Therefore, it's minus 2n. And then plus, what was the value for c? The value for c was equal to 1. All right, guys. So that is the formula for the general term for this pattern. Okay, guys. So A is answered. Okay. So now for B, we need to determine the seventh term. We need to determine the seventh term for this pattern. Okay. So this is easy. Okay, the seventh term for the pattern, we already know that the general term, okay, for this sequence is equal to, right, Tn, which is equal to 4n squared minus 2n plus 1. And we're trying to calculate the seventh term for this sequence, right? So we're trying to find the value, okay, of the term that is in its seventh position. So you're going to substitute the 7 where you see an n. It's going to be 4, 7 all squared minus 2 times 7 plus 1, right? Okay, so it's 4. 7 times 7 is equal to 49 minus 2 times 7 is equal to 14 plus 1, and that is equal to 183. Okay, guys, so this is easy marks once you've got your formula on lockdown. Moving on, guys. Now we need to determine which term, right, is equal to 241 on our sequence. Okay, so with all these questions, you just need to remember that you always really all the time need to rewrite the equations so that you don't make a mistake. So I already know that the general term for this sequence is equal to Tn, which is equal to 4n squared minus 2n plus 1, right? So we need to determine which term is equal to 241, right? So we already know that that term is equal to 241. So you just substitute the 241 into your Tn, okay? Because that's the value. And now we need to determine the position of that term on our sequence, right? So already we're trying to solve for n, okay, because we're looking for the position. We're trying to solve for n. Obviously, to solve for n, we need to, okay, move everything or get your equation into its standard form. Okay, so to get it into its standard form, you need to get 0 on its own, and you're going to have 4n squared minus 2n plus 1 minus, because it moves from the left hand side to the right hand side, 241. Okay, we're going to continue to simplify this. Minus 2n, positive 1 minus 241. How much do you get? Okay, you get negative 214. Right, so now we can already see that, okay, this equation, okay, we can already see that this equation, it's in its standard form, right? It's in its standard quadratic form. So because it's in its standard quadratic form, we can use the quadratic equation, the quadratic formula to solve this equation. Or you can just simply find the factors of 240 that if you plus or minus them will give you negative 2, and if you multiply them together will give you negative 240. But if you're not about that complication and you really just want to be substituting things and solving this question really quickly, you can simply just use the quadratic formula to solve for n, which is equal to, I don't like the color of this, I'm not sure if you guys are going to be able to see this, let me make it in let's make it blue. Okay, right? So you can just simply use the quadratic formula, which is equal to n is equal to minus b plus or minus, right, b squared minus 4ac, right, all over 2a, right? If you substitute, we already know that your a is equal to, so this is our a is equal to 4, your b is equal to negative 2, and your c is equal to negative 240. So you just simply substitute those values into our equation. We are not going to complicate our lives, guys, okay? We're not going to complicate our lives. I'm just going to change it into black, right? So it's minus, right? Minus, what is our b? Minus 2 plus or minus, what is our b? Minus 2 all squared minus 4. What is our a? It's 4. And what is our c? Negative 240, right? All over 2a. Okay, you are simply going to punch this into your calculator. Okay, simply going to punch this into your calculator. And then what do you get, guys? Right, when you punch this into your calculator, you get that, right, your n is equal to 8. You get n is equal to 8, right? Or n is equal to negative 7.5, right? Guys, this is where you're supposed to have your light bulb moment. Okay, we are trying to determine which term is equal to 241 on the sequence. We're trying to determine the position of this 241, right, on our sequence. So if you are thinking, right, does this say, this is the light bulb that I'm talking about. This is a light bulb moment. Can that term be equal to negative 7.5? It cannot, guys. Okay? It cannot. So this is where you're supposed to be thinking and not just going, and just answering without thinking. This is where you're supposed to think. And your thinking is supposed to tell you that I cannot have a negative 7.5. This value is impossible because n represents the position of a term on the sequence. So therefore, that position needs to be a positive natural number. It cannot be a negative 7.5. Okay. Right. So the negative 7.5 is invalid. Right? N cannot be equal to negative 7.5. Okay. But our n can be equal to 8. Therefore, all right, 241 is equal to, is the 8th term in the sequence. Okay. Okay, guys. So therefore, 241 is the 8th term. Okay. All right, guys. So, guys, that's it for today. I'm just going to quickly do a recap. A very, very quick recap. So, today, what we looked at is a quadratic sequence. Okay. So we looked at a quadratic sequence, and we know that when you are working with a quadratic sequence, all right, there is a second common difference. Okay, there's a second common difference, right? So that is what we were checking for when we were doing our calculations here. Okay, and we found that our second common difference was equal to 8. Okay, found that our second common difference is equal to 8. And then, right, to be able to answer our questions, Okay, there are three very important equations that we need to remember. We need to memorize. Okay, actually four. But this one is easy because we already know the standard form of a quadratic equation, right? Which is Tn is equal to an squared plus bn plus c. So this one is easy. But the other three equations that you guys really need to remember is that 2a is equal to the second difference. Né? You need to remember that 3a plus b is equal to t2 minus t1. And we also need to remember that the equation a plus b plus c is equal to t1. Guys, if you don't remember these equations, you are not going to be able to answer your questions. So you need to remember them. You need to memorize them. Okay? Because once you have remembered that, then you can simply substitute using what is given to you and what you've calculated. It becomes easy. Okay, we found that our A was equal to 4, we found that our B was equal to -2, and we found that our C was equal to 1. All right, so after finding these values, what did we do? We simply just substituted them into our general equation of Tn is equal to an squared plus bn plus c, and we found the formula for our nth term, okay, for this quadratic sequence. Moving forward, the questions really got easier. Okay, what we did, we had to basically calculate the seventh term for this pattern, right? And we found that the seventh term for this sequence was equal to 183. And lastly, we had to determine which term, right, is equal to 241. Right, so by substituting 241 into our Tn, okay, we were able to basically have our 0 on the left hand side of our equation, so that you have a standard form of a quadratic equation. After seeing that we have got a standard form of a quadratic equation, it really becomes simple to solve for n, right? Because you can simply just use the quadratic formula, or you can use the whole method of inspection to just find the factors of 240, that if you plus or minus them together will give us -2, or if you multiply them together will give you a -240. But if you don't want to complicate your life like that, you can just simply use the quadratic formula, because it makes life so much easier. And by using the quadratic formula, we found two values for n, which is n is equal to 8 and n is equal to -7.5. And then we had a light bulb moment that okay, we're trying to find a term, a position, right? We're trying to find a position of a number on a sequence, right? And if it's -7.5, that should not make sense, okay? Because it needs to be a positive natural number, okay? Okay, guys, don't forget to like, comment, and subscribe to my channel, and please share the channel with students that are in high school that are doing mathematics, and please also share it with matriculants, because we are currently preparing for our final exams. Okay, guys, thank you so much. See you guys on my next upload. Goodbye.